Imagine something so powerful that not even light, the fastest thing in the universe, can escape from it. Imagine space itself being bent and twisted so extremely that time slows down and matter gets stretched apart. That's not a scene from a science fiction movie. It's a real object in our universe, and it's called a black hole. Today, we're going to explore what black holes are, how they form, the different types that exist, and why they matter so much to our understanding of the universe. So, what exactly is a black hole? At its simplest, a black hole is a region of space where gravity is so strong that nothing can escape. Not particles, not radiation, and not even light. That's why we call it a black hole. We can't see them directly, but we can tell they exist because of how they affect our surroundings. For example, a black hole can make stars object strangely or cause matter to heat up and glow as it falls in. At the very center of a black hole is something called a singularity. This is the point where we all think the mass of the black holes is compressed into infinite density. It's a place where the laws of physics as we know stop making sense. Surrounding the singularity is the event horizon. You can think of the event horizon as a point of no return. If anything crosses it, a planet, a spaceship, or even light, it can't escape. It's trapped forever. Now, how do these mysterious objects form? Most black holes are created when very massive stars reach the end of their lives. A star spends most of its life balancing two forces. On one side, there's gravity, pulling everything in, and on the other side, there's nuclear fusion, which pushes outward as a star burns hydrogen into helium and produces energy. But when a star about 20 times bigger than our Sun runs out of fuel, fusion stops. Without that outward push, gravity takes over. The star collapses under its own weight, and this collapse is so extreme that it crushes the star's core. This event usually triggers a spectacular explosion called a supernova. For a short time, the star can outshine entire galaxies. What's left behind, if the star is massive enough, collapses further and becomes a black hole. Not all black holes are the same. Scientists categorize them into different types based on their size. The first kind are called stellar black holes. These are formed from collapsing stars and usually weigh up to about 20 times more than our Sun. Then we have supermassive black holes. These are giants, millions or even billions times heavier than the Sun, and every large galaxy we've observed, including our Milky Way, has one of these monsters sitting at its center. In fact, our galaxy's black hole is called Sagittarius A, and it's about 4 million times the mass of our Sun. There's also evidence that there may be intermediate black holes. These are bigger than stellar ones but smaller than supermassive ones. They're hard to find, but scientists think that they might form when smaller black holes merge together. Now, why should we care about black holes? Black holes aren't just destructive objects, they play an important role in shaping the universe. For example, many galaxies, including our own Milky Way, seem to be held together partly because of the supermassive black holes at their center. Studying black holes also helps scientists test theories of physics. For example, Einstein's theory of general relativity makes very specific predictions about how black holes should behave, and observing them gives us a way to test whether those predictions are correct. And perhaps most importantly, black holes push the limits of human knowledge. At the singularity, where density becomes infinite, our current physics simply breaks down. That means black holes might hold the key to developing new theories of space, time, and the universe itself. So, black holes are not just cosmic monsters. They're essential parts of the universe, shaping galaxies, testing physics, and challenging everything we think we know about space and time. Now that we know what black holes are and how they form, in the next video we'll explore something even scarier. What would happen if you actually fell into one? That's all for today, and thank you so much for watching.